Hello and welcome back to the Web Demystified. In the previous part of this video we learned about different types of selectors in CSS. In this video we'll explore the box model and the display property. We'll also learn about CSS units, browser compatibility, colors, and CSS frameworks. There are two types of HTML elements: block and inline. Block elements always start on a new line and take up the full width available. Inline elements do not start on a new line and only take up as much width as necessary. So, first let's talk about block elements. Imagine them as the building blocks of a web page. Each block element starts on a new line and stretches out as wide as its container allows. Think of them like bricks in a wall, each occupying its own space. Examples of block elements include the div, the backbone of website layouts, p tags for paragraphs, and heading tags like h1 to h6. Now let's shift our focus to inline elements. Inline elements are like the words within a sentence. They sit comfortably alongside other elements and text without forcing a line to break. This means they only take up as much width as necessary. Notable inline elements are span, perfect for styling a part of text, A for links, this A, and tags like strong and EM for emphasizing text. Strong and EM. You can turn a block element into an inline element by setting its display property to inline. And vice versa, you can turn an inline element into a block element by setting its display property to block. In the example, you can see that the A tag is an inline element by default, but we can turn it into a block element by setting its display property to block. This is useful when you want to make the entire link clickable, not just the text. In the second example, you can see that the div tag is a block element by default, but we can turn it into an inline element by setting its display property to inline. And one more thing to note is that inline elements do not have a width and height. They only take up as much width as necessary. So, if you set the width and height of an inline element, it will be ignored. Now let's discuss the box model. In CSS, the term box model is used to describe how elements are displayed on the page. The CSS box model is essentially a box that wraps around every HTML element. It consists of margin, border, padding, and the content itself. The size of the box is determined by the content of the element, the padding, the border, and the margin. The margin is the space between the border and the other elements on the page. Also, the margin is transparent. The border is the line around the box. It goes around the padding and content. The padding is the space between the content and the border. Padding is transparent in CSS as well. It creates space around the content inside an element, but does not have a color. However, the background color or image of the element extends into the padding, making it appear as if it has a color. For example, we can add here background color. Let's set it green. And our padding is green now, but it's transparent. And the content is the actual text or image inside the box. The box model allows us to add a border around elements and define space between elements. For example, we can increase margin, and the space between the boxes will be bigger. Also, we can increase the size of our border, and it will be bigger as well. To calculate the total width of an element, you need to sum the width of the content area, the left and right paddings, the left and right borders, and the left and the right margins. And same applies to height. You need to sum the height of the content area, the top and bottom paddings, the top and bottom borders, and top and bottom margins. We have already discussed the display property, but here's some additional information about it. The display property in CSS determines how an element is rendered on the page. It controls whether the element is treated as a block or inline element, and it also affects the layout of its children. The display property has two types: the outer type, which determines the element's participation in flow layout, and the inner type, which determines the layout of its children. Different values of the display property have their own specifications. None. The element stays in the DOM, but it completely ignored while rendering of the document. Flex. The element is rendered as a block-level flex container box, and the child elements are rendered as flex items. Child elements of a flex container are laid out in the flex formatting context, and the flex item elements are laid out in the flex container box. The flex layout model is used to lay out items in a one-dimensional row or column. For example, we can use flex direction row or column. Also, we can use row reverse and column reverse. Grid. The element is rendered as a block-level grid container box, and the child elements are rendered as grid items. The grid layout divides a page into major regions, defining the relationship in terms of size, position, and layer between parts of a control built from HTML primitives. Additionally, grid containers' child elements can position themselves so that they actually overlap and layer. Sadly, not all web browsers can use all CSS properties. Usually all the CSS properties work on all browsers, but new ones only work on a few. You can use the Can I Use website to see if a CSS property works on a certain browser. This site has the latest info on which browsers support which CSS properties and JavaScript features. For instance, the display grid feature, display grid, came out in 2017, and Chrome version 57 and later supported, Edge version 12 and later, Safari version 10.1 and later, and so on, but it only partially supported on Internet Explorer. The site also has info on mobile support. Another example, arrow functions. In JavaScript, arrow functions are a shorter way to write function expressions in JavaScript. They use a new symbol that looks like a fat arrow. They came out in 2015, and all browsers support them except for Internet Explorer. Units in CSS are used to specify the measurement of properties. For example, the width and height properties define the size of an element. There are two types of units, relative and absolute. Relative units are based on something else, such as the font size of the parent element. Examples of relative units include %, rem, em, dh, and vw. On the other hand, absolute units are not relative to anything. They have fixed values. Examples of absolute units include pixels, points, centimeters, millimeters, and inches. It's good to remember that 1 pixel is equals to 1/96th of 1 inch. Since rem are relative to the font size of the root element, user can change the font size into system settings and the font size of the element will change accordingly. For example, if I open settings in my web browser and set the font size to very small, the font size of this paragraph that has font size 3 rem became smaller. Rem is more preferable than em because it's relative to the font size of the root element. For example, if I add here HTML selector and type here font size 10 pixels, for example, let's set it to medium, and set the font size to 10 pixels, the font size of this element is changed as well. And em is relative to the font size of the ancestor element. So, if you change the font size of the ancestor element, the font size of all descendants elements with font size in em units will change accordingly. For example, we can change font size in the body and our paragraph with 2em font size changed. Great! Also, there are few more relative units such as vh, percentage relative to the viewport height, and vw, percentage relative to the viewport width. To set the color of an HTML element, you can use the color property. The color property specifies the color of text, and it can also be used to specify the color of borders and backgrounds. The color property can be set to any valid CSS color value. A color value can be a color name, a hex value, an RGB value, or an HSL value. It is crucial to understand how to interpret color codes in CSS rather than simply writing them. CSS provides several methods for specifying colors. Here are the most commonly used ones: RGB, hex, and HSL. The RGB color model is an additive color model in which red, green, and blue lights are added together in various ways to reproduce a broad array of colors. The name of the model comes from the initials of the three additive primary colors: red, green, and blue. The RGB color model consists of 3 digits, each of which has a value between 0 and 255. The first value represents the amount of red, the second, the amount of green, and the third, the amount of blue. For example, to set the color red, we need to type RGB 25500, and the color green is defined as 02550, and the color blue is defined as 00255. To set the color white, you need to remember that white is a mixture of all colors, so you need to set all values to 255. Now this box is white. And the color black is defined as RGB 000. This is because black is the absence of light. In IDEs like VS Code, you can use the color picker to select a color. Simply click on this square before color value, and the color picker will appear. Here you can drag the circle to select a color, or you can enter the color value manually. So let's take a closer look at the color picker. When I'm sliding the lightness slider, you can see that every value is changing. Same for the hue slider and for every other slider. So here we can't see the direct relationship between the position of the sliders in the color picker and the color value. But don't worry, we'll find a way to fix this. The hexadecimal color model is a color model that specifies colors using a combination of red, green and blue, just like RGB color model. To set color with a hexadecimal color model, you need to specify the amount of red, green and blue on a scale of 0 to 9 and A to F, where 0 is the lowest value and F is the highest value. Every color can be defined either with 3 digits or with 6 digits. For example, the color red is defined as F00, where the amount of red is F and the amount of green and blue is 0 and 0. The color blue is defined, the color green is defined as 0F0 and the color blue is defined as 00F. To define black, you need to type # and 3 zeros, just like in RGB, 3 zeros. And to set color white, you need to type FFF. It's important to note that 3-digit colors are not only shorter and easier to read and use, but also less accurate than 6-digit definition. 6-digit colors are more accurate and were created for this reason. For example, I can set something like F5, E5, F8, just like in our previous videos, but I can't set this color with 3 digits. Using 6 digits allows us to specify more colors, more precisely than with 3 digits. The reason for using 6 digits is that every symbol takes exactly 1 byte. In hex color model, sliding the sliders in the color picker may be more confusing than in RGB color model, because every value is changing. The HSL color model specifies colors using hue, saturation and lightness. The HSL color model consists of 3 variables. Hue is a degree on the color wheel from 0 to 360, where 0 is red, 120 is green and 240 is blue. And 360 is red as well. Saturation is a percentage value where 0 means shade of gray and 100 is the full color. Lightness is also a percentage value where 0 represents black, 50% represents neither light nor dark, more like true color, and 100% represents white. In every color model, you can also specify the opacity of the color. The opacity is a percentage value where 0 represents complete transparency and 1 represents opaque color. I can set here 0.5 for example, and this is 50% transparent now. With the HSL color model, you can see a direct relationship between the position of the sliders in the color picker and the color value. For example, when I'm sliding this slider horizontally, you can see that the third value, lightness, is changing from 50% to 100%. And when I'm sliding this slider vertically, here, you can see that the lightness value is changing from 0% to 50%. When I'm changing this slider, hue slider, you can see that the first value is changing. And to see saturation changing, we need to slide our slider horizontally as well. Also, you can use the color picker to convert colors from one model to another. For example, from HSL to RGB, or from RGB to hex, or from hex to HSL or any other color model. And important note that in every color model you can add the fourth value, which is opacity. For example, in RGB I can add the fourth value, 0.5, and as you can see our color is 50% transparent. Or we can add this in hex color model or any other color model. CSS stands for Cascading Style Sheets, and the term cascading refers to the way CSS rules are applied to HTML elements. Cascading is the process of combining various style sheets and resolving conflicts between different CSS rules and declarations, when more than one rule applies to a certain element. For example, I can set in body selector color light blue, and the paragraph text is light blue now. But if I set color red here in class selector, the color of the text is red. Why? This is because class selector has higher specificity than body selector. Also, I can add font size here, 20 pixels for example, and let's set color blue in my ID selector, Now the text is blue. In CSS, if there are any conflicts, the rule with the higher specificity will override the others. ID selector has higher specificity than class selector. Since there is no conflict with font size property from class selector rule will be applied. This is a key aspect of cascading in CSS. And that concludes the second part of our video on CSS fundamentals. We covered a lot of ground, from the box model and display property to CSS units, browser compatibility, colors, and CSS frameworks like Bootstrap and BEM. Thank you for watching the Web Demystified. Stay tuned for more exciting web development content. Goodbye, and see you in the next video.